Learning objectives. At the end of this topic, you will be able to understand the properties of rational numbers. Under this topic, you can learn the closure property, commutative property, and associative property of rational numbers. Introduction. You frequently come across simple equations to be solved. Consider the example x plus 3 is equal to 10. We get x is equal to 7. The natural number 7 satisfies the given equation. On the other hand, if we have the equation x plus 3 is equal to 3, we get the whole number x is equal to 0. If we consider only natural numbers, this equation cannot be solved. To solve the above equations, we need to add the number 0 to the collection of natural numbers and obtain the whole numbers. Even whole numbers will not be sufficient to solve equations of type x plus 15 is equal to minus 12. Minus 12 is a negative integer, which is not a whole number. We have enough numbers to solve all simple equations with the available list of integers. For example, 4x is equal to 5 and 3x plus 2 is equal to 0. In this equation, we cannot find a solution from the integers. We need the numbers 5 by 4 to solve the equation 4x is equal to 5. We need the number minus 2 by 3 to solve the equation 3x plus 2 is equal to 0. Using the different types of numbers seen so far, here you will learn some properties of operation. Properties of rational numbers. Let us first discuss about closure property under whole numbers. Addition under whole numbers. 0 plus 2 is equal to 2 is a whole number. If we add two whole numbers, 5 and 2, again we get the whole number 7. Whole numbers are closed under addition. In subtraction, 0 minus 5 is equal to minus 5, which is not a whole number. If we subtract two whole numbers, say 2 minus 5, we get the integer minus 3, which is not a whole number. Whole numbers are not closed under subtraction. In multiplication, 0 multiplied by 2 is equal to 0 is a whole number. If we multiply two whole numbers, say 5 multiplied by 2, we get 10 is again a whole number. Whole numbers are closed under multiplication. In division, if we divide two whole numbers, say 4 divided by 6, we get 0.67, which is not a whole number. Whole numbers are not closed under division. We learn from the calculation done so far that whole numbers are closed under addition and multiplication, but not under subtraction and division. Next, let us discuss about closure property under integers. If we add two integers, say minus 8 plus 4, we get minus 4 is an integer. Is minus 3 plus of minus 2 an integer? Yes. Minus 3 plus of minus 2 is equal to minus 5 is an integer. In the same way, if we add two positive integers, say 5 plus 3, we get an integer 8. Hence, if we add one negative integer and one positive integer, we get an integer. If we add two negative integers, we get an integer. If we add two positive integers, we get an integer. In general, a plus b is an integer for any two integers a and b. Hence, integers are closed under addition. Children, now we subtract two positive integers, say 6 and 5, which is equal to 1 is an integer. What about 5 minus 6? If we subtract 5 minus 6, also, we get an integer minus 1. Now let us subtract with one negative integer and one positive integer. Say minus 4 and 2. Minus 4 minus 2 is equal to minus 6 is again an integer. In the same way, we subtract two negative integers, say minus 2 and minus 4, we get an integer 2. Finally, let us check the subtraction with positive integers, 2 and the negative integer minus 4. 2 minus 4 is equal to 6 is an integer. In general, for any two integers a and b, a minus b is again an integer, and b minus a is also an integer. Hence, integers are closed under subtraction. Here let us multiply two positive integers, say 4 into 5 is equal to 20 is an integer. If we multiply one negative integer with one positive integer, say minus 4 and 5, minus 4 multiplied by 5 is equal to minus 20. What will you get when you multiply two negative integers? For example, minus 4 into minus 5 is equal to 20. 20 is an integer. In general, for any two integers a and b, a multiplied by b is also an integer. Integers are closed under multiplication. Last operation is division. If we divide two positive integers, say 4 divided by 7, we get 0.57, which is not an integer. Integers are not closed under division. From this table, you learned that integers are closed under addition, subtraction, and multiplication, but not under division. Closure property under rational numbers. You know, a number which can be written in the form of p by q, where p and q are integers, is called a rational number. In your earlier classes, you have learned how to add two rational numbers. Let us add a few pairs of rational numbers here. If we add two positive rational numbers, say 3 by 2 plus 5 by 3, we get the rational number 19 by 6. If we add a positive rational number, 3 by 2, and negative rational number, minus 7 by 5, we get 1 by 10. Rational numbers are closed under addition. When we subtract two positive rational numbers, say 4 by 5 minus 3 by 7, we get rational numbers 13 by 35. In the same way, if we subtract two negative rational numbers, say minus 7 by 4 minus 1 by 3, we get minus 17 by 12. Minus 17 by 12 is also a rational number. Therefore, rational numbers are closed under subtraction. In multiplication, if we multiply a negative rational number with positive rational number, say minus 3 by 2 into 5 by 3, we get negative rational number minus 15 by 6. If we multiply two negative rational numbers, say minus 2 by 7 into minus 4 by 5, we get the rational number 8 by 35. Therefore, rational numbers are closed under multiplication. In division, if we divide two positive rational numbers, say 4 by 5 divided by 5 by 3, we get a rational number 4 by 3. In the same way, if we divide two negative rational numbers, say minus 6 by 2 divided by minus 7 by 5, we get 15 by 7. But any integer divided by 0 is not defined. Therefore, rational numbers are not closed under division. From this table we learnt, rational numbers are closed under addition, subtraction and multiplication, but not under division. Commutativity under whole numbers. You come across commutative property under addition, subtraction, multiplication and division. Here let us check commutative properties under whole numbers. In addition, 0 plus 4 is equal to 4 plus 0 is equal to 4. 1 plus 5 is equal to 5 plus 1 is equal to 6. for any two whole numbers a and b. A plus b is equal to b plus a. Therefore, we can say that addition is commutative under whole numbers. Next, let us check the subtraction with whole numbers. 0 minus 2 is equal to minus 2. But 2 minus 0 is equal to 2. 4 minus 2 is equal to 2. If we subtract 4 from 2, that is 2 minus 4 is equal to minus 2. For any two whole numbers a and b, a minus b is not equal to b minus a. Subtraction is not commutative under whole numbers. In multiplication, 0 into 3 is equal to 3 into 0 is equal to 0. 5 into 2 is equal to 2 into 5 is equal to 10. For any two whole numbers a and b, a into b is equal to b into a. Multiplication is commutative under whole numbers. The last operation is division. Here we divide two whole numbers, say 4 divided by 2 is equal to 2. But 2 divided by 4 is equal to 0.5. So for any two whole numbers a and b, a divided by b is not equal to b divided by a. Division is not commutative under whole numbers. From this table we learnt commutative under addition and multiplication, but not under subtraction and division. Commutativity under integers. As we have done before for commutativity under whole numbers, here we will do commutativity under integers. In addition, 2 plus of minus 4 is equal to minus 4 plus 2 is equal to minus 2. For any integer a and b, a plus b is equal to b plus a. Addition is commutative under integers. In subtraction, 3 minus of minus 5 is equal to 8. On the other hand, minus 5 minus 3 is equal to minus 8. For any integer a and b, a minus b is not equal to b minus a. Subtraction is not commutative under integers. Multiply 5 into minus 4 is equal to minus 4 into 5 is equal to minus 20. For any integer a and b, a into b is equal to b into a. Multiplication is commutative under integers. Commutativity under division. Divide two integers, say minus 6 divided by 3 is equal to minus 2. But if we divide 3 divided by minus 6, we get minus 0.5. For any integer a and b, a divided by b is not equal to b divided by a. Division is not commutative under integers. Children, what have you understood from this table? Yes, integers are commutative under addition and multiplication, but not under subtraction and division. Commutative property under rational numbers. Here let us add a few pairs of rational numbers under commutative property. For example, if we add positive rational number 6 by 4 and a negative rational number minus 3 by 5, we get 18 by 20. If you interchange and add the rational numbers, you will get the same rational number. If we add two negative rational numbers, say minus 1 by 2 plus of minus 3 by 7, we get minus 13 by 14. As we have done before, interchange and add the negative rational numbers, we get minus 13 by 14. Therefore, addition is commutative for rational numbers. If we subtract two rational numbers, say 5 by 2 minus 3 by 4 is equal to 20 minus 6 by 8, we get 14 by 8. If we interchange and subtract the rational numbers, 6 minus 20 by 8, we get minus 14 by 8. Therefore, we can conclude that subtraction is not commutative for rational numbers. Now we multiply two rational numbers. Minus 1 by 4 into 3 by 5 is equal to minus 3 by 20. If we multiply 3 by 5 into minus 1 by 4, again we get the same rational number, minus 3 by 20. Therefore, we can say multiplication is commutative for rational numbers. Here we divide the rational number minus 1 by 3 divided by 2 by 5. We get minus 5 by 6. If we divide 2 by 5 divided by minus 1 by 3, we get minus 6 by 5. Division is not commutative for rational numbers. From this table, you have learned that rational numbers are commutative under addition and multiplication, but not under subtraction and division. Associative property under whole numbers. In the last class, you have learned two properties related to addition of whole numbers: the closure property under addition and the commutative property. Now let us see another property, associative property related to addition of whole numbers. Now let us try adding three whole numbers. What is 2 plus 3 plus 4? First case, let's try adding them. First, we will add 2 plus 3. So 2 plus 3 is included inside brackets to show that this operation should be performed first, and then we will add 4. So adding 2 plus 3, first we get the answer as 5. Then add 4 to it. So we get 5 plus 4 is equal to 9. In the second case, let us group 3 and 4. We write it as 2 plus, inside the brackets, write 3 plus 4, which indicates we need to add 3 plus 4 first. We get 2 plus 7, which is equal to 9. Here again, the answer is 9. Let's try another way to add these three numbers. So here, we will first add 2 and 4. Write 2 plus 4 in brackets, indicating we need to add them first and then plus 3. Now we add 2 plus 4, we get 6. And we need to add 3 to it. What is the answer? 6 plus 3 is equal to 9. So we see in all the three cases, even though the grouping was different, we get the same answer, which is 9. So here we have learned when we add a 2 plus 3 plus 4, add 2 plus 3 first and then add 4 to it. Or add 3 plus 4 first and then add 2 to it. Or add 2 plus 4 first and add 3 to it. And we get the same answer, 9, in all the three cases. So what is associative property of addition? When we add whole numbers 3 or in more numbers, the sum doesn't change even if the grouping is changed. Now let's see the other property, subtraction of whole numbers. Let us try to subtract 3 whole numbers. What is 6 minus 4 minus 2? We can do it in different ways. While subtracting 3 or more whole numbers, we can subtract by grouping them in different ways. First, let us try to group 6 and 4 and subtract them first and then subtract 2 from it. So, 6 minus 4 is equal to 2. Bring down minus 2 here, which is equal to 0. Now let us try another way. This time we will group 4 and 2. So this becomes 6 minus of 4 minus 2. We know 4 minus 2 is equal to 2. So it becomes 6 minus 2 and this is equal to 4. So what do you learn from this? When we change the group for subtraction, the answer is not the same. Hence, while subtracting the whole numbers, the result changes when the grouping is changed. So we can say associative property does not hold true for subtraction of whole numbers. Associative property under whole numbers. Here let us see associative property with relation to multiplication of whole numbers. Multiplying 3 whole numbers. What is 2 multiplied by 3 multiplied by 5? We can multiply these numbers in 3 different ways. First case, multiply 2 and 3 first, then multiply by 5. So 2 into 3 is equal to 6. And then multiplied by 5, we get the answer as 30. In the next case, multiply 3 and 5 first and then multiply 2 to the result of the product. So it becomes 2 multiplied by 15, since the product of 3 and 5 is 15. So we get the answer as 30. There is one more way to multiply these three numbers. First, we will multiply 2 and 5, and then we will multiply by 3. The product of 2 and 5 is 10, and then multiply with 3. We get 10 multiplied by 3 is equal to 30. What do we see in all the three cases? Whichever grouping we did between two whole numbers, the answer is the same, which is 30. So what did we see when we multiplied the three whole numbers? We can group any two numbers for multiplication, but the answer is always the same. So what do we learn from this? In multiplying whole numbers, the product doesn't change even if the grouping is changed, and this property is called associative property of multiplication. Next, let us see the other property, that is associative property related to division of whole numbers. Now let us try to divide three whole numbers. What is 15 divided by 5 divided by 3 equal to? We can group them in different ways, and let us see if the answer is the same in both the cases. So first we will group 15 and 3, so let's divide 15 by 3 first. 15 divided by 3 is equal to 5. And then we bring divided by 5 down here. Now we get 5 divided by 5 is equal to 1. Now let us try the other group. So here we will group 3 and 5 first. What do we get while grouping 3 and 5? We get 15 divided by 3 by 5. We know the reciprocal of division is multiplication. Here we write 15 multiplied by 5 by 3, since the reciprocal of 3 by 5 is 5 by 3. Now, 3 times 5 is equal to 15. So, the answer is equal to 5 multiplied by 5, which is equal to 25. In the first case, we got the answer as 1. And here we've got the answer as 25. So what we can say is, associative property does not hold true for division of whole numbers. So in the division of whole numbers, the result changes when the grouping is changed. Associative property under integers. Let's see another property, that is associative property related to addition of integers. Now let's try adding three integers, -2 plus -3 plus -5. First, let us try adding -3 and -2. This gets reduced to -5 plus -3 plus -2 is equal to -5. Now we need to add -5 and -5, which is equal to -10. Next, let us try adding the same expression, and here we will get -3 and -5, and then we will add -2 to it. So we get -2 plus -8, since the addition of -3 and -5 is 8. If we add -2 and -8, we get -10. So what do we see? When we add -2 and -3 first, and then add -5, or if we add -3 and -5 first, then we add -2 to it, the answer is the same in both the cases, which is equal to -10. What do you learn from this? We can say, in addition of integers, the sum doesn't change even if the grouping is changed. This property is called associative property of addition. Now we shall learn associative property related to subtraction of integers. What is 2 minus 7 minus 5 equal to? So first we will subtract the group 2 and 7. What is 2 minus 7 equal to? As we know, we will subtract just the absolute values, 7 minus 2, and put the sign of the higher absolute value number, which is 7 here. So the answer would be -5. And this problem gets reduced to -5 minus 5. Here, -5 minus 5, we just add the absolute values, 5 plus 5, which is equal to 10, and put the common sign, which is negative. So the answer here is -10. Now let's change the grouping. This time we will do the subtraction of 7 and 5. So 7 minus 5 is equal to 2. So this problem gets reduced to 2 minus 2, and we know 2 minus 2 is equal to 0. What do we see? When we change the grouping, while subtracting three integers, the answer is not the same. And you know this means that associative property does not hold true for subtraction of integers. While subtracting three or more integers, the result changes when the grouping is changed. Associative property under integers. Now we shall learn associative property related to multiplication of integers. Now let's try to multiply three integers. Minus 3 multiplied by minus 2 multiplied by 5 equal to. Here we are multiplying three integers. So first let's multiply the two integers first. In this case, we will multiply minus 3 and minus 2 first. So minus 3 multiplied by minus 2, and then we multiply by 5. Here 3 multiplied by 2 is 6, and we know minus multiplied by minus becomes plus. So the answer here is plus 6. So this problem gets reduced to plus 6 multiplied by 5, which is equal to 30. Now let's take another group, which is 3 multiplied by 5 first, and then we multiply by minus 2. Minus 3 multiplied by 5. Here we are multiplying positive integer by negative integer. So the answer would be a negative integer, and the product is 3 multiplied by 5, which is equal to 15. Putting the negative sign becomes minus 15 multiplied by minus 2. Again, we have two negative integers. So the answer would be positive number. 15 multiplied by 2 is equal to plus 30. So the answer is 30. Now let's take the group of minus 5 and 2 first and then multiply. So we get 5 multiplied by minus 2, then we multiply by minus 3. 5 multiplied by minus 2. We know it would be 10 with a negative sign, so this is equal to minus 10 multiplied by minus 3. Here we multiply two negative integers, so the answer would be a positive integer. 3 multiplied by 10, and the answer would be 30. What do we see even when we change the grouping? The answer is the same, which is 30 in all the three cases, whether we group minus 3 and minus 2, or we grouped minus 2 and 5, or we grouped 5 and minus 3, the product was always 30 only. You know this means that associative property of multiplication holds true. This says, while multiplying integers, the product doesn't change even if the grouping is changed. Here we shall learn associative property of division under integers. Now let's try to divide three integers. Minus 16 divided by 4 divided by minus 2. Are these two the same even if we change the order? In this, let's take the group of minus 16 divided by 4 and then perform the division. We can do it the other way too. We can first take the group of 4 and minus 2 and perform the division first. Will these two result in the same number? Let us see. First, minus 16 divided by 4 and then divided by minus 2. Minus 16 divided by 4. We know 16 divided by 4 is 4. And a negative number divided by a positive number gives a negative number as the answer. So the answer here would be minus 4. Then we divide by minus 2. We know 4 divided by 2 is 2. When we are dividing one negative number by the other negative number, the result is always a positive number. So here we get the answer as plus 2. Now let's take another group, which is 4 divided by minus 2 first and solve it. So minus 16 divided by, we will solve 4 divided by minus 2, we get 2. When we divide a positive number by a negative number, the answer is a negative number. So we get 4 divided by minus 2 as minus 2. The problem gets reduced to minus 16 divided by minus 2. 16 divided by 2 is 8. And we know when we divide a negative number by another negative number, the answer is always a positive number. So the answer here would be plus 8 or just 8. What did we see? When we changed the grouping while performing division of three integers, we saw the answer is not the same. Hence, minus 16 divided by 4, then divided by minus 2 is not same as minus 16 divided by 4 divided by minus 2. Thus, the result changes when the grouping is changed, and this means the associative property does not hold true for division of integers. In the division of integers, the result changes when the grouping is changed. Associative property under rational numbers. Let us take any three rotational numbers. Let's call them a, b, and c. Add a plus b first, and the result of this will be added to the third rational number c. So let's start with that. So the three numbers that we have taken, for a is -2 by 3, b is 3 by 5, and c is -5 by 6. First add the numbers inside the brackets as you studied in your earlier class. Before adding this, convert the rational number with different denominator to equivalent irrational number, and then proceed with addition as shown over here. When you simplify this, you get -1 by 15. Now we add this with -5 by 6. Same method, you again make the denominator the same and proceed with the addition. Here both the numbers are negative. -1 by 15 is added to -5 by 6, and the resultant is a negative number. So we get -27 by 30. If we reduce this to the lowest form, we get -9 by 10. Now let us try the other one. In this case, we add first b plus c, and then we add a. In this case, -2 by 3 as it is. First, we will add 3 by 5 plus of -5 by 6. When we simplify this bracket, we get over here is -7 by 30, and then we add the sum that we got, -7 by 30 to -2 by 3. And when we simplify this again by making the denominator the same, we get -27 by 30, and simplifying it, we get -9 by 10. So what we have proved for three numbers, it doesn't really matter the way when you're adding three numbers, the way in which you group them gives you the same result always. In addition to rational numbers, the sum doesn't change even if the grouping is changed. This property is called associative property of addition under rational numbers. Now let us try to do the same thing for subtraction. So in this case, we follow the same method. So we will first subtract two numbers a minus b, and then subtract c from the result of subtraction. So the number here is -2 by 3 minus of -4 by 5, and then subtract -1 by 2. When we simplify inside the brackets, keep in mind, we have to understand that these are negative numbers and there is a negative sign between the numbers. When we open up the bracket and simplify, we get 2 by 15, and then we have -1 by 2. When we simplify it, we get -11 by 15. Now let's do it by grouping b and c first. That is, we do b minus c, which is shown over here. In this case, first we simplify minus of 4 by 5 minus 1 by 2. When we simplify this, we get -13 by 10. So it becomes -2 by 3 minus 13 by 10. When we simplify this further, we get -59 by 30. In the first case, we got the answer -11 by 15. In the second case, we got the answer -59 by 30. From this, we can say that these two are not equal to each other, and therefore we conclude a minus b minus c is not equal to a minus of b minus c. When changing the grouping while subtracting three rational numbers, the answer is not the same. And you know what it means is that associative property does not hold true for subtraction of rational numbers. Now let us look at the proof for associative property under rational numbers. So we proceed with multiplication for rational numbers. Here we take three rational numbers a, b, and c, and we first multiply ab, that is, we have the first product by grouping a and b together, and then we multiply this product with c. So the three numbers that we use is minus of 7 by 3 multiplied by 5 by 4 multiplied by 2 by 9. When we simplify this, that is, we simply multiply minus 7 with minus 5 and then multiply 3 with 4. So we get minus 35 by 12 multiplied by 2 by 9, and then we proceed in a similar way. So we can actually simplify this further because you have 2 over here and 12 in the denominator. So we cancel 2 times 6 is 12. When we simplify this, we get minus 35 by 54. So this is the result of A multiplied by B and then multiplied by C. Next, let us look at what will happen if we group B and C. So here we have minus 7 by 3 multiplied by 5 by 4 multiplied by 2 by 9. First, solve the numbers inside the bracket. 2 times 2 is 4. So we get 5 by 18. So it becomes minus 7 by 3 multiplied by 5 by 18. Multiply the numerator and denominator, we get minus 35 by 54. In both the cases, we have the same result. We observe associative property holds true under multiplication. That is, for any rational numbers a, b and c, a multiplied by b multiplied by c is equal to a multiplied by b multiplied by c. Now let us take a look at division for rational numbers. So we follow the same method. We take 3 rational numbers a, b and c. So we first divide a by b and then we divide the result of this by c. Let us take a as 1 by 2, b as minus 1 by 2 and c as 2 by 5. As we discussed earlier, we convert the division into multiplication by changing the numerator and the denominator. So what we have is 1 by 2 multiplied by minus 2 by 1. So that these two get cancelled out here and we have just 1. So we have to remember that this is a negative sign. So we have minus 1 by 1 divided by 2 by 5. Again, we apply the same operation into multiplication by exchanging the numerator and denominator. So we get minus 1 multiplied by 5 by 2. So we get the result as minus 5 by 2. Let us do this division in another way, that is, first divide b by c and then divide this by a. So 1 by 2 divided by, inside the bracket, group minus 1 by 2 divided by 2 by 5. Proceeding in the same way as we did earlier, converting the division into a multiplication. Multiply both the numerator and denominator, we get minus 5 by 4. So the next step becomes 1 by 2 divided by minus 5 by 4. Again, converting division into multiplication, and when we simplify, we get minus 2 by 5. You can see that these two numbers, minus 5 by 2 and minus 2 by 5, they are not equal. And this is sufficient condition to say rational numbers are not associative under the operation of division. Summary. Let's summarize the topic. Closure property. Whole numbers are closed under addition and multiplication but not under subtraction and division. Integers and rational numbers are closed under addition, subtraction and multiplication but not under division. Commutative property. Addition and multiplication is commutative for whole numbers, integers and rational numbers, but not commutative under subtraction and division for whole numbers, integers and rational numbers. Associative property. Addition and multiplication is associative for whole numbers, integers and rational numbers, but subtraction and division is not associative for whole numbers, integers and rational numbers.